Hello everybody, my name is Xavier Briand with a D, not a T. And I'm senior web developer at Experience Point. So, big news, you are working with Symfony framework and you have a website with a lot of content, okay? What you want to do, you or your boss or I don't know who, you want to be able to search efficiently in this content. And now you are an amazing developer, you accept the challenge. So the question is, how to search easily and efficiently in a Symfony website application. So I've worked on 3 big websites this year. Big websites, French websites, where I implement search engine. So I've got the search bar on the top. So e-commerce. Another one for PHP framework. Another search engine. And a small PHP community. Another search engine. And for each of these projects, I use Solr, Apache Solr. So what is Apache Solr? Apache Solr is a standalone search engine providing a REST-like API, and it's written in Java. Okay, got a lot of features. You got an administration page. It's scalable, adaptable, extensible. Of course, you can do full text search in it, and blah 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 blah. There is a lot of features, like duplicate document detection, including fuzzy near duplicates. Just remind that there is a lot of feature in it. And Solr is built on top of an index called Lucene. So this is the main index where you put your content, and Lucene is used by Twitter, Apple, Wikipedia, and LinkedIn. Solr is used by all these big companies. So, Java application, heavy, blah, 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 very complicated to install. Not very much. Here are 4 steps to make your Solr server run. Okay? Download the archive, unarchive this archive, go into the Apache Solr, blah, blah, blah example, and just run the .jar. And that's it. By doing that, this simple step, you have a fully featured administration page where you can see your schema, see the configuration, do some analysis on your query or on your index. You can get some statistics, and you can do search, of course. And you also have access to a fully featured example website with search, boosting features. You've got some things with maps, so managing coordinates. You've got facet fields, etc., etc. So really easy. So we have our Symfony application. We have our Solr web server, search server, and we need something in the middle. We need something to do the request, the queries inside Symfony. We need to do the query inside Symfony to Solr and get back the results, and we don't want to do that by hand. So we're going to use a bridge. If you go on the Solr wiki page, Solr PHP, you get a bunch list of PHP library to manage Solr, and I choose, in this project, I choose Solarium. Solarium is a well-made library to build your query, like the query builder in Doctrine, for instance. And as you are in an amazing community, there is a bundle to use this library. You can use, for instance, the Nelmio Solarium bundle. So, we've got Symfony, we've got Solr, and Solarium to do the queries. The tools. So now the first thing to do is to put your content, to put it in the Solr index, okay, to index your content. By default, Solr provides you one index, it means one schema, and in this schema you have several fields. Okay, so this schema is defined in the schema file. And in this schema file, you define your fields. Okay, so fields have a name, have a type, and some other attributes to define this file. So you can index stuff. You can say that stuff are stored because sometimes the indexes process destroy the actual content. So you want to store the initial value and make some fields required or not. An indexed field is a field against which you can do a search. So in this example, I will have a unique ID, which is mandatory in the index. So ID, a description field to put all my content, and a path to get back this content. So maybe the URL or the slug of the page where is my content. So I don't really want to do to search my path. I don't want to search the URL, so I don't actually index this field. Okay, so those fields have types. So we've got string types, so it is a string. And you've got more complex type like the text underscore general type, and this type is defined under. So you can define your own types. And types, complex types, like the text field, which or like the text underscore general, which extends the text field Solr class, have something special called analyzer. And analyzer will declare how you index your data. So to be able to search inside a field, we have to do some stuff. Okay. So step by step, the first thing we do is we tokenize the content. So we split the content into several parts, usually words. Then we use a filter to remove stop words. So all the words like the, on, of, all the words you don't want to search. Then I use a synonym dictionary to maybe transform a word into two other words, or to transform two words into one word in my index, depending on what you want to do. I lowercase everything, and I use a stemmer to remove all the grammar stuff of words. So in this example, I'm looking for Wi-Fi. If I tokenize this, I am looking for Wi-Fi token. Then I remove all the stop words, so just keeping looking at Wi-Fi. I use my synonym dictionary to transform Y-Fi into Wi-Fi. So I only want to store one version of Wi-Fi. I mean Wi-Fi, Y-Fi. I want to store Wi-Fi. Lowercase everything, and then use the stemmer to keep the look part of looking. If I index another things completely different, James looks at the Wi-Fi signal. Same thing, tokenize. Sorry, stop words, synonyms, in this case nothing, then lowercase, and then the stemmer. And we see that in two different contents, we can find some similar token. So look and Wi-Fi in this case. Now in Symfony, let's say we want to index some blog post. So inside my, let's say, doctrine entity, I can add a new function to transform this entity into a Solr document. So I use, of course, Solarium, and that's really easy. So I get back my title, I put my ID into the ID field of my doc. I concatenate my title and my body of my blog post into the description field, and I put the slug of my blog post into the path. And then I return the document. And then I create a Solr index command, where I get back from the container of the Solarium service. I create an update query. I transform all the blog posts I want into Solr documents. I put those documents inside the if.that query. I add a commit to actually put this document inside my index, and then I execute my command, my update command. So transform, submit. Okay? So now your content is indexed. Not so difficult. Next step, of course, is search inside this index. This can be the content of one of your actions. So first thing, get back from the container my Solarium service. I create a query request, a select request, and I want to search foo spacebar inside the description field. Okay. I want to have the first 10 results, and I do the query. I send the result set variable to my tweak template, and just have to loop on this result set array to display each of my results. And of course, I can display the content of the description field. Very complicated. Whoops, sorry. So, how are ordered the results? By relevancy. So there are some key concepts to know in Solr. TF, IDF, coord, length norm, and boosting. So TF is stands for term frequency. So the more your term is frequent inside the content, the more it will weigh. It will be important. Inverse document frequency is that if the word you search is very rare inside your content, it will weigh much more. Coordination factor, it is for if you search for two keywords, let's say foo and bar, and you match foo and you match bar, obviously you will have the results will be more important than if you only match foo. Length norm means that if you match a keyword inside a smaller field, it will be more important than if these keywords match inside a big field. And last, the boosting factor. If you want to make one of your field more important or one of your document more important inside your index, you can boost this field or this document. You can boost document at indexing time, and you can boost fields at query time. So let's say, in the case of our blog post, we want to make that the title field in my database weigh much more than my text field. So first thing to do, obviously, it's to add a new field inside my Solr index. Name title, same type. I want to index it. I want to store it. I change, of course, the index command, blah, blah, blah. I re-index everything. And I'm going to use a specific query parser called edismax that enables the boosting stuff. And I can set my query fields to say that my title fields will be 2 times more important than my description field. Okay? Now let's talk about some big feature. Faceting. Faceting is a way to organize my results inside categories. It can be things, grouping things according to the content of one field, or it can be grouping things according to things that I've set inside the query. So maybe by price range, or by the cat field if I have electronics or connector or music things inside this field. So how to set up that? Same things, very complicated. When you do your query request, you call the facet component. You create a new facet field called cat, which gonna facet on the category field. If I have a category field inside my index, of course. And in my template, I will, in my result set, get back this component and get back the results of my category facet. I'll loop on it, and I can display the facet value and the number of results of my search inside this facet. So next thing to do is to add a link on this facet to be able to click on it and to reduce the scope of my search. So we want to filter our results. So one way to do that is just to do a query, basic query. So I want to search chocolate inside my blog post with the category book. Okay, so I can do that like that. But it's not very the best way to do it. the best way to do it is just to search chocolate, and I will build a query filters that will filter my index by category, and in this case by the book category. And by doing that, I will create a subset of my index, put this subset in memory, and the next time I'm going to search inside this book category, it's going to be much more faster. So this is the way to filter. It is a good way to filter. Now, let's add some contrast in our results. Yes, I'm a search in this search engine. I search for form, and my form keywords are highlighted in the results. It's good. So to do that, we have to enable. We have to use the highlighting component. So same thing. I get back my query. I call the highlighting component on it. I want to enable this highlighting component on the description field, and I can also specify the prefix and the postfix of the highlighting words of your search. And then, again, inside your view, you can loop on the results and get back the results of your highlighting component like that. Again, really complicated. Now, what happened? I can find the results. RESLUTS. Damn it. Let's use a spell checker. Okay. So the spell checker component is not enabled by default inside the configuration of your Solr index, so you have to enable it. So look for this spell check things inside the Solr configuration and remove the command. Not so complicated. Then inside your controller, again, get the spell checker component, set the query, misspelling. You want to collect the results, so gathers have a good results. And then if you have no results in your search, maybe it means that the word is not the good one, so you want to look for inside your spell checker results if you have a corrected fixed result. So you can loop on the spell check things, so suggestion, or inside the most important results, correction fixed, which is the correction. And then you can. It's basically the did you mean features in Google. Not all about that, but it's one of the part of this feature. Okay, more other features. Now I want to start to type my search and already get results. Yes, I can do it. Easy. So let's say in this small community PHP websites, I want to type my name. I begin Xavier, and I already get results. Amazing. And I can, click on it. So basically, it means that when I search for serve, it will match service container. Okay? So how to do that? I'm gonna add a specific field type inside my index called suggestors, and I will add a specific analyzer. So as you can see, now I've got an analyzer at index time and another one at query time. I don't want to do the same thing at query time and at indexing time on this index. So when I'm going to index the content, I'm going to use a specific tokenizer that will put all my content inside one token. And then I will use a specific filter called edge n-gram filter. And I want this filter to generate small chunk of my token from 3 letters to 15 letters. So basically, if I index service container, I will index these values. And now, as I store these values, I'm able to make match ser with service or service space co. And if you want to do the drop-down thing, you just have to use a jQuery UI or something else. Okay. So you're able to get the result of your research with just a small part of your research. You're able to highlight things. You're able to filter things. You're able to boost some of your results according to your configuration or document per document. And now you want to, you've got in the blog post, you have got some content in French, let's say, and in English, and you want to search on this content. And remember, in the field, we use stemmer to remove all the grammar stuff from my words, and this stemmer is really tied to the language. So English stemmer is not the same thing that French stemmer, and French have all the cool stuff like UTF-8 characters, you know, like accent, like all the stuff, and maybe you want to index some Chinese or some Japanese or, you know, cool language. So you have to have specific fields for that. And you don't really want to, in your index, to add a field per language. It's not very scalable. It's not the good way to do that. And think about it. You don't really want to search in French inside your English content. It doesn't really make sense. Sometimes not. So let's talk about the multicore features. We're going to add an index for the French content and another index for the English content. Multicore means you have several indexes, so several schema.xml file, and also you've got multiple configuration for this schema. Okay? So on the top, my previous configuration for my index, so inside the Solr.xml file, I'm going to change from one collection 1, to 2 new core, the English and the French core. And I move from this trees of configuration to this new tree of configuration. So each inside the directory core_en and core_fr, I get new configuration file and I get new data file. So my index will be separated completely. And now at the query time, I just have to select on which index I'm going to use, to do the search. Cool. The coolest thing is that you can do that without having to restart the Solr process. You can use the administration API to unload the previous core, you move all the things, of course, and you do the new configuration. And after that, you can ask your Solr API to create 2 new core, the English and the French one. And now, without having to restart the processes, you get your 2 new cores. And you can also ask some status on these cores. You can reload if you want. You can rename a course. You can alias a core if you want. And you can also swap between cores. So let's say that you've got 2 cores, one live and the other is not live. And when you index things inside when you index inside an index, obviously, it's gonna slow down your search performance, because while you index, you do things on this index. So while you search, it's gonna be slower. So what you can do is, having an index live, do the search on this index, and the other one, which is a copy of the live one, you can index on it. Okay, add your new document. And then when you're ready, just swap your 2 index. And multicore also mean replication. So you can set up replication between your cores. You can load balance now, because if you have replication, you can load balance from one to the other one. So if you have some performance issue, it's going to be the good way to do that. Or you can shard your index in 2 index. That's cool. That's very powerful. And let's speak a bit about the new version, which is now a beta version of Solr, but the Solr 4 version, which will introduce something called Solr Cloud. Solr Cloud is something more powerful, more scalable for the cloud things, the cloud. So it's basically based on a shard replicated, managed by a zookeeper. If you want to index things on the core, you have to put the things on the memory. You have to commit things on inside the index. You have to write things on the disk, and you have to relaunch a lot of things to make this new index searchable. So it's speed heavy. So if you want to index results and to query immediately these results, it's not very possible. You have to use a lot of power, a lot of memory to do that. Solr 4 will introduce the near real-time search. So you will be able to put data into memory, and without having to write this data inside the index on the disk, to search directly inside those memory. So it's going to be much more faster. Yes, near real-time search. And a lot of other cool features. So let's sum up. We've made a lot of stuff. Okay, so this is my action. It's a bit, a lot of stuff inside my actions. Not really cool. Okay, got things to create, to query, to limit the number of results, do my boosting, do my filtering, do my faceting, highlighting, misspelling, blah, 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 blah. Okay. Solarium introduced a cool thing, which is a plugin. So you can add plugin to Solarium to do things, okay? And you can overload some hook or plug it. You can deploy it in some hooks, like before you create the request, after you create your request, or before Solr handles the results. You can change things everywhere. It's really cool. And Symfony provides as well as cool stuff called DIC, the Dependency Injection Container. So we're going to use that. So let's overload the Solarium service, and add your our own service to do auto-suggest query. So I get back the Solarium results. I register a new plugin, which is a service defined under, and this service has a dependency, let's say, on the router service. And inside my plugin, what I'm going to do is I'm going to overload the actual query. So instead of using the Solarium query, I will use my own query on my bundle. And I will be able, as I know now I have in dependency the router, I can, before that Solarium create the results, I can maybe generate routes, the actual absolute URL of my results, with the router from the path field I have on my index. So now when I will send to my jQuery stuff pre-generated URL, and in my drop-down menu, I'm going to just have to click on it without having to do some client-side route generation. And all the stuff that I add inside my controller, I can now move that inside my new query, my new select query, or my new auto-suggest query, as you want. Usually in the project, you don't have so much query. Just basic select one, maybe a more advanced one, and yes, the auto-suggest stuff. So all the things I add in my controller, I can move that there. Cool. So inside my bundle now, I've got my plugins and my queries. Cool way to organize stuff. And you can also, if you want, inject directly inside your request, your query. You can inject the request service, and from the request service, of course, you can get back the search term. You can get back the page, so to do offsets and limits, the filter values, etc., etc. So you will not have so much things to do in the controller now, because everything is going to be done inside your own query objects. Cool, high five. From your content to the Solr index, you're now able to search very efficiently because you can fine-tune your search by maybe filtering, highlighting, spell checking, etc., etc. This is our journey. So from indexing to searching, you know more about MULTICORE as well. Yes, a lot of stuff. So I hope it was not so complicated to set up, and I'm sure you will be prepared now to implement a Solr search engine, which is very simple. Thank you. If you have some questions, if you want to index always, if you generate a lot of content, you want to index a lot, you will have some issues, some performance issues, because indexing is really heavy, an heavy process. That's why you can use more dynamic stuff like I don't remember the name of the other search engine, Cloud Machin, blah blah, Elasticsearch. Okay. And in your case, you will maybe want to use the beta feature of the Solr 4 version, the near real-time search, which enabled you to, without having to do all the heavy stuff, directly search on the memory of the Solr instance, which is much more faster. So, first things, Solr index is not meant to store content, just to index content to be able to search on it. But the Solr 4 version also defined the index as document storage. So you're gonna be able to do some join inside your index. So now, yes, it's gonna be a database. So if you put content inside the index and you want to retrieve this content, the real content, you have to enable in the field the store attribute. So set the store attribute to true. It will not destroy the content. It will make your index much more bigger because you have to store a lot of things. And then you can do a search. So maybe do a search by, I don't know, by ID, like in your database. And yes, recreate your entities and persist that again. But usually what you want to do is to be able to, if you change your index, you have to re-index everything. So you don't want to, you want to have a main source and the index. Or you can index from a database, but you can also index from a file, you can index from a web service, you can index from a lot of things. And Solr provides also an active way to index things, so you can ask Solr to fetch results inside the database and index it for you. Or from a file, from a web service as well. There is a lot of adapter in Solr to do that without having to push things on Solr. Good question. I never really used this beta feature, so I'm not able to fully respond to answer your question. But I'm really sure that when you do the request, it will request on your index and expand this request to the memory. So you will get back the things you have. And maybe the question was about duplication. So if you re-index something that is already in the index, so as you have to provide a unique ID for each of your documents, I'm pretty sure it will be able to make the index match and to keep the more recent document. So the one inside the memory, obviously. Thank you.